Alex, one of the great questions of humanity from time immemorial has been the question of origins, the beginning of the universe. Now, we know that the universe has been expanding, so now this looks like there has been a beginning, and people argue about it from a physics point of view, and some people from a philosophical or theological point of view. But in terms of the hard science, I want to come to you as a cosmologist who has been very intimately involved in the beginning of the universe and ask that question. Did the universe have a beginning?
Well, one thing that we know for sure is that we live in the aftermath of a great explosion that we call the Big Bang. The universe, about 14 billion years ago, the universe was extremely dense and hot and rapidly expanding. And we now see the afterglow of that explosion in the form of the cosmic microwave radiation. And we have very solid evidence that this explosion really happened. Now, was that the true beginning of the universe? Actually, cosmologists now believe that it was not, that there was a stage prior to the Big Bang, which is called inflation. That is a very rapid, accelerated expansion of the universe.
Of the space itself?
Of the space, yes. And it ended basically with the Big Bang. Still, the question remains, what happened before inflation, if anything? And it appears that a satisfactory answer can never be given, because I can keep asking, and what happened before?
Well, let's dissect those two pieces apart. Let's first talk about the Big Bang itself. You said it was very hot, very dense. How hot? How dense?
Well, we cannot tell exactly what the maximum temperature was. But we can tell for sure that the temperatures were in about billions of degrees.
Okay. And we know from Einstein's equation E equals mc squared that with so much energy and so much heat, the matter could begin forming out of that tremendous energy.
That's right. The density was above the nuclear density, that's for sure, and probably much, much greater than that.
Oh. So it's a huge amount per square centimeter. I mean, numbers that we can't even put names to.
Probably.
Okay, so that was the Big Bang, and that was the explosion from that enormously hot energy. Now, before then, we have this period of inflation. Now, that lasted much less than 1 second, right?
Inflation lasted, we don't know exactly how long inflation lasted, but in a tiny fraction of a second, inflation expands a very small region, subatomic region, to a size much bigger than the whole observable universe.
So in far less than a second, the entire universe, which was less than a subatomic size, expanded to greater than what we can, totality of what we see today.
That's right.
Now, some people would say that seems to be contradictory because nothing can go faster than the speed of light, but this is different.
Einstein's theory of relativity tells you that you cannot run faster than light.
Right.
So if you are in a contest, you're running, and the signal of light running, signal of light always wins.
Right.
But if you have expansion of space and you have two objects separated by some distance, there is no limit on how fast that distance can grow.
Okay, so now we have this incredible period of inflation prior to the Big Bang, so inflation ended in the Big Bang, in a sense.
That's right.
Okay, so now we want to say what's before inflation, or that's what we were talking about. Can we even make comments about that?
So this infinite regress of questions of what happened before. There is one scenario that breaks out of this infinite regress, and that is somewhat popular now among the cosmologists. And this is the scenario that the universe could originate spontaneously out of nothing. This sounds like a very strange proposition for a physicist to make, because we know that there are conservation laws, that energy is conserved, right? So usually this means that if you have nothing, you cannot have something, because that takes energy. However, it turns out that if you have a closed universe, where the space closes on itself, like in 2 dimensions, the surface of the Earth closes on itself. And 3-dimensional space can close on itself in a similar way. so that you go in some direction and you come back to the same point after you traverse the whole universe. So in such a closed universe, the gravitational energy, which is always negative, exactly compensates the positive energy of matter. So the energy of a closed universe is always zero. And then nothing prevents this universe from being spontaneously created.
Because the net energy is always zero.
That's right.
The positive matter balanced by the negative energy of the gravitation of that matter, which is the space-time curvature.
That's right. Yeah. And other things include, for example, total charge, electric charge, which is also conserved.
Right.
In a closed universe, if you think of a charge and electric field goes out of it, then it has to converge to the opposite charge on the other side, so to say. Mm-hmm. So as a result, the total charge of a closed universe is always zero as well. Mm-hmm. So there is no conservation law that prevents the formation of such a universe. And in quantum mechanics, actually, if something is not forbidden by conservation laws, it necessarily happens with some non-zero probability. So a closed universe can spontaneously appear out of nothing. And there is, in fact, an elegant mathematical description of this process, where a tiny closed universe having very high energy spontaneously pops out and immediately starts to expand.
Okay, but when we say that this quantum mechanical fluctuation, appears out of nothing and we have the balance of energy, and so we're in conformity with the conservation of energy laws, yet you need the laws of quantum mechanics. You need some pre-existing environment that can enable this to happen.
That's true. This is a very perplexing mystery that in this picture, the same laws that describe the evolution of the universe also describe the appearance of the universe, its coming into being. And this seems to suggest that the laws were there prior to the universe itself. When I say that the universe is created out of nothing in this picture, by nothing I mean not only the absence of matter, but also the absence of space and time. Right. So where did those laws exist? So we seem to get a picture where the laws of physics have some Platonic existence which is independent of the universe.
So the laws of physics may be existing in some, as we say in philosophy, necessary way, perhaps, or some other mechanism. Other people may have different ways that they came into existence, but we need to have those pre-existing, just like numbers may pre-exist in some way. Even if there's nothing, there has to be the number 8. I mean, there's a concept of a number 8.
That's right. Well, pre-existing is maybe not precisely the right word because there is no time.
Yes, that's right.
So
that's right.
Prior doesn't really...
Yeah, it's explanatorily prior,
right.
But it can't be temporally prior.
That's right.
But back to the fundamental question then, did the universe have a beginning and therefore time had a beginning at a moment? And the evidence, what you're saying is that there was this big explosion, there was this inflation, and what happened before that is very speculative. But there is this initial explosion that set everything into being.
What we can tell is that inflation cannot be continued back indefinitely. Oh. As I said, we don't know how long inflation lasted, but it couldn't last forever. Therefore, either there was something prior to inflation, and it's hard to imagine what that could be. An alternative is this creation of nothing from nothing, and in fact, this is a quantum mechanical process. So, if it can happen for one universe, then there should be many universes created in this way with different initial conditions. And if you do the analysis, you find that the most likely way for the universe to start is to be in this high energy state which drives inflation. The prediction of this quantum origin model agrees with the theory of inflation. It provides the right initial condition.